In this video, we will be talking about splicing of pre-RNA, also known as hnRNA or heterogeneous nuclear RNA. Let's remind ourselves that DNA gets transcribed into hnRNA, which is essentially like a premature mRNA. So this hnRNA needs to be polyadenylated, capped, and spliced before it's called mRNA. In this video, we will be talking about the mechanism in which splicing occurs. The first thing that happens is the RNA combines with small nuclear riboproteins, also called snRNPs, as well as some other proteins to form the spliceosome. The spliceosome, as you can see over here, will cut the 5' splice site to form a lariat-shaped loop. Another name for the 5' splice site is the donor site, and the 3' splice site is also called the acceptor site. So after you cut the 5' end, or the donor site, you can see that it has a free 3' OH group, and this OH group goes and attacks the phosphate on the 3' acceptor site. So now this will effectively get rid of this intron right here. And now you can see down here, this phosphate group is connecting the two exons. Something to note is that it's weirdly important for you guys to remember that there is a GU sequence, as you can see right here, at the 5' splice site, and an AG sequence here at the 3' splice site. I don't really know why they think this is important, but tests seem to like this fact. So something that can come up is, you have a mutation of one of these and there's an issue with splicing. And something interesting about this is that certain mutations of these sequences in the 5' donor site can cause issues with splicing, which I just said, but this can lead to beta thalassemia. Beta thalassemia is a blood disorder that reduces the production of hemoglobin, which is the iron-containing protein in red blood cells that carries oxygen to cells throughout the body. So in people with beta thalassemia, low levels of hemoglobin lead to a lack of oxygen in many parts of the body. Something else to note is that issues with snRNP assembly can cause diseases such as spinal muscular atrophy, and these patients get degeneration of the anterior horn of the spinal cord, which leads to weakness or what people call floppy baby syndrome. Additionally, if you have antibodies to the spliceosomal snRNPs, these are called anti-Smith antibodies, which can be seen in a disease called lupus. Now let's sum up the important parts of this video. RNA combines with snRNPs to make the spliceosome. The spliceosome cuts at the 5' site, which is the donor site, and that has a GU sequence and an OH group that will then attack the 3' acceptor site that has an AG sequence and a phosphate group. Issues with splicing can cause beta thalassemia and spinal muscular atrophy, and antibodies to snRNPs are found in an autoimmune disorder called lupus. Thank you for watching this video, and if you got this far, please give this video a like. Comment below with questions or if you want us to make a video on a different topic. Lastly, don't forget to subscribe so you don't miss a future video.